Okay, so I'm going to cover 13.1a and 13.1b. They are very, very similar equation, or very similar notes to each other. The difference is that 13.1a is exponential growth, and what's 13.1b?
Decay.
Exponential decay. Now, I want you to take a minute, and if you were to flip back and forth between this side and the other side, what differences do you see? What was that? Virtually none. That is correct. So what differences do you see? Because there are some minor differences. It's not a whole number in the decay. Interesting. That's really the only difference between today's notes, or the 13.1 notes, and the 13.2 notes. The only difference is that when we're graphing exponential growth, we have this formula. Where can I write it? Y equals AB to the X, and we'll throw an H and a K on there in just a minute. But when we have Y equals AB to the X, this B value has a special name. It's called your growth factor, or in a decay equation, it's called your decay factor. Sometimes it's known as a multiplier, but in growth equations, that B value is bigger than 1. Okay? In decay, that B value is not bigger than 1. It's between 0 and 1. So it would most often be something like 1/2 or 1/5, as opposed to on the growth side where we don't use 1/2 and 1/5, we use their reciprocals, which are 2 and 5. That's the only difference other than the way the graphs look, and I'm going to show you the difference between the way the graphs look. Okay? So, I'm going to jump down to this box down here at the bottom. Now, this box is almost identical to the one in the same place on the next page. This is your basic equation. I showed you Y equals AB to the X. Well, if you throw an H and a K on there, that's what your equation looks like. Where is the H? It's in the exponent with the X, which means that it is technically in parentheses. So what does that tell us? We're going to have to change the sign just like we always have with H. K is out at the end just like it always has been. Let's see. A represents a vertical stretch or compression still. B this time is not your horizontal stretch or compression. It's called your growth factor. Or in a decay equation, it's called your decay factor. In growth, it's bigger than 1. In decay, it's between 0 and 1, like I showed you. H is still a horizontal shift. You are also going to be using H for your center X value. There's not really a center to these graphs. There's not a vertex. There's not an inflection point, something like that. So it gets a little tricky to set up your XY chart unless you have a place to start. So we're going to use H as our place to start. K is still a vertical shift. Okay? Now, an asymptote. Have you ever heard of an asymptote? That might be a new word for you. It is a horizontal line at Y equals K. We'll talk more about that in a minute. Domain, range. Domain is all real numbers. Range is Y is greater than K or Y is less than K, and we'll talk about that in a minute also. Excuse me. So let's go up to the very first equation here. Y equals 2 to the X. Now with exponential growth, there's actually a lot of parent functions. Y equals 2 to the X is a parent function of all the Y equals, or all of the graphs with base, or with a B value of 2. Y equals 5 to the X would be a parent graph for all of the graphs that have a B value of 5. Okay? So there's not just one parent graph for these guys, which is kind of funky. All right, some things we need to identify this. What would you say is the H value of this equation? Remember, H is up in the exponent with X. Is there anything up in the exponent with X? Nope. So what would you say H is? 0. Now in that box at the bottom, what did I say h was? Use h for your center x value. So if h equals 0, that's how we got that guy right there. That's how we start our XY chart. And this one's already set up for us, so that's helpful. What would you say K is? 0. There's no number outside. That means K is also 0. Guess what K represents? My asymptote. So if K equals 0, my asymptote is the line y equals 0. It's always the line y equals k. Now, I did something first period, and let's see if this helps you at all. Taylor, can I borrow you for a minute? Sure. Can you go stand up against the whiteboard? Now, I'm going to ask Taylor a strange question. You ready? Taylor, can you stand in the exact same place as the wall? No. Can you get closer to the wall? Can you get closer? No. That's about as close as you can get, right? There is no physical way that she could be standing in the exact same location as the wall, correct? She can get as close as she wants to it. We could melt her against it, right? But she can never actually stand in the same place as the wall. That wall is like your asymptote. You're never, ever, ever going to touch your asymptote, or never going to be able to be in the same place as it. You will, however, get super, super close to it, but you can never touch it. And do you think she can cross through the wall? Not unless her middle name's Casper, right? So are we going to be able to cross through our asymptote? No. So you want to think about your asymptote like a wall. Thank you. Okay, so if my asymptote is y equals 0, I'm going to take a highlighter or a different color. If I don't have a highlighter or a different color, you must do a dotted line for your asymptote. Reason being, your asymptote is not actually part of the graph of y equals 2 to the x. It's a boundary for it. So it cannot be graphed the same as your actual graph. So that's the wall that we can't cross. That is the line y equals 0. I do want to see you labeling that line on your assignments and on your test. Okay? All right, so let's plug some of these values in. If x is -2, notice the 0 was in the middle, and we just filled in values around it like we've done a million times before. So, if my equation is 2 to the x, I'm going to start off with 2 to the -2nd power. What does that give me? 0.25. Why does it give me a decimal? Because 2 to the -2nd is the same thing as 1 over 2 to the 2nd, which is 1 over 4. What's -1 going to get me as an exponent? 1 over 2, which is 0.5, right? What about 2 to the 0? 2 to the 1st? 2 to the 2nd? 4. Now with these graphs, oftentimes you'll have decimals on one side and nice numbers on the other. Excuse me, it's just the way it works out. All right, -2.25, and yes, I'm in the yellow area because my pen has some thickness to it, but I'm not touching the axis, am I? I'm not actually touching that line, the black line, right? -1.5, 0, 1, 1, 2, and 2, 4. Okay, so it's clearly going up on this side. And on this side, it's never, ever, ever going to cross through that asymptote. It's just going to get closer and closer and closer and follow it along. Questions about that? Now let's talk about what exponential growth is. Exponential growth is the same idea as if you were given a penny every day for a month. And let's say that penny, one extra, how does it go? One extra penny every day, you get one more penny every day, or your amount doubles every day, that's it. So let's say you got 1 penny the first day. How many would you get the second day? 2. So how much money do you have now after 2 days? 3 cents, right? How much would you get the next day? 4 pennies if we're doubling each time. So now you have 4, 5, 6, 7 cents. Then you would get 8 pennies, and then 16, and then 32, and you would add them all up to get your total that you've made, right? This is called exponential growth because it's not just adding 1 penny each day. This day you're adding 1 penny, but this day you're adding 2. And this day you're adding, and then from here to here you're adding 8. So you're not just adding 1 penny every day. You're adding a bigger amount every day. That's an idea of exponential growth. Another example of exponential growth I used in my first period class, and it had to do with rabbits. So let's say you have 1 mama rabbit. I'm not going to get into the whole biology of how rabbits reproduce, but let's say you have 1 mama rabbit, and she has 1, 2, 3, 4, 5 babies. That means you got 6 rabbits there, right? What if each of those babies then have 5 babies? Then you have 5, 10, 15, and I stopped drawing because I was tired of drawing rabbits. 5, 10, 15, 20, 25, 36 rabbits already, just 2 generations out. Rabbits are crazy like that. Okay? That's why you'll see those things that say spay and neuter your pets, because cats and dogs do the same thing. They reproduce at a rate where if they have 5, and each one of their puppies have 5, or each one of their kittens have 5 when they grow up, it's crazy how many you'll end up with. Okay? And there's no way that people can take care of them all. So, that's the idea of exponential growth, which is why it's not a line. It's not increasing at the same rate. The rate is changing the entire way you go. So, this is exponential growth. You see the growth part where it's going up? That's our growth part. Exponential growth is something you like to see in a bank account. Yes, you want your balance to start here, really low, and you want to magically make it get really high. But unfortunately, usually it ends up being a little bit more like, not quite that. We'll see. Okay, get the idea of what we're doing here? What would my domain be? Are there any boundaries left to right? Left, I see an arrow, so is there a boundary there? No. Right, there's an arrow this way, which means it's going to keep going up and to the right, slowly to the right, but it'll keep going to the right. Domain is going to be all real numbers. For all of these graphs, your domain is all real numbers. The range will either be y is greater than k or y is less than k. Do you think this one's going to be y is greater than k or y is less than k? Greater than. If it's above that asymptote, it's greater than. If it's below the asymptote, it's less than. Why is it not greater than or equal to? Because it can't be in the same place as the asymptote. So my asymptote's at 0, my range is y is greater than 0. Not too shabby? Let's go ahead and fill this in. The horizontal asymptote, your equation is always y equals k, just so we got that. And let's move on to another one. Let's look at this guy. How is this one different than the one we just did? There's a negative in front of it. What do you think that's going to do? Let's think about this for a minute. In our equation, y equals ab to the x, what would you say a is? Maybe that's a hard one. What would you say b is? B is what has the exponent on it, correct? So what's b in this problem? It's 2. It would only be negative 2 if there was parentheses around the negative 2. So if B is 2, what do you think A is? Negative 1. So that negative is actually representing an A value of negative 1. What do you think an A value of negative 1 does? Vertical reflection, just like it always has. What is H? What is it? 0. And K? Also 0. So H tells us what? It tells us the starting point of our XY chart. And then we're going to fill in values around for the rest of it. What does K tell me? I heard someone say it. It's my asymptote. So did my asymptote move from the previous problem? Nope, my asymptote is still right here. And what's the equation of that asymptote? Y equals 0. Now, when I ask you on your test for the asymptote, you can't just say 0. Because 0 is a fantastic number, but it's not a line. A line has to have an equation. Y equals mx plus b. Well, with a horizontal line, there is no slope, so the m and the x drop out. But this is y equals mx plus b form. So make sure you have that y equals there. All right, so let's plug these values in. Now, a question as I go to plug this into my calculator. Is this negative sign in parentheses? No. So when I go to plug it into my calculator, I can't put parentheses around it. You don't want the negative in parentheses if it's not in parentheses there. So I'm going to write negative 2 like that, no parentheses. Exponents you typically do want to put in parentheses, especially if there's an h value. So the exponent I am going to put in parentheses, just always a good habit to get into. The bottom part, though, don't put parentheses unless there are parentheses given to you in the problem. All right? So, negative 2 to the negative second power is negative 0.25. All right? Negative 2 to the negative first power, negative 0.5. What are you noticing here? It's negative, but it's the same numbers, isn't it? Okay, let's plug in 0. Thank you. I get negative 1. What if I plug in 1? Negative 2, and 2, negative 4. Those are the exact same values, just negative. So let's see what that looks like. Negative 2, negative 0.25. Negative 1, negative 0.5. 0, negative 1. 1, negative 2. And 2, negative 4. Do you see the vertical reflection? But Mrs. Franken, that's going down. How does that represent exponential growth? It's what's growing? It's growing negatively, I heard someone say. That's fantastic. Some people like to refer to it as growth reflected. The way I think about growth is any time, remember on a graph we read it from left to right, so if you were walking from left to right, if you are getting further away from your asymptote, that's exponential growth. Okay? If you're going to get closer to your asymptote as you're walking from left to right, that's exponential decay. But further away makes it exponential growth. Okay, let's try this guy. I'm going to skip this one. This is exactly the same. The only difference is the B value is 5, which means what? When you plug in 5 to the first, you're going to have 5. When you plug in 5 to the second, you have 25. 5 to the third, 125. You're going to get really big numbers in here. And sometimes that happens. The bigger this number is, the steeper and the quicker this is going to get. Okay? It's almost like it becomes closer to being a right angle there almost, like a corner. Yeah?
For the range on that one, if y is less than 0?
Yes. My domain here is still all real numbers. My range, since it's below my asymptote, is going to be y is less than 0. So? All right, let's do this guy. Going in the habit of the other ones, what would you say is the A value? What would you say it is? There's nothing in front of the 2, so what does that mean? It's a 1. It can't be a 0, because if it was a 0, 0 times anything would be an issue. What is the B value? 2. What is H? Anything up there with the X? So H is 0. And what is K? 3. So, which one helps me with my XY chart? H. So H helps me with my XY chart.
H is the exponent?
Yep. From right there. What tells me my asymptote? K. So K is no longer at 0, it's now at 3. Just in case there's the question that comes up, all of these asymptotes are all horizontal for these graphs. So what's the equation of my asymptote? Y equals 3. All right, so 0, -1, -2, 1, and 2. Mrs. Franken, all 3 graphs you've done have x values of -2 to +2 on your table. Is it always going to be -2 to +2? No, it depends on what your h value. All 3 of these happen to have an h value of 0, which is why it wound up that way. We will see one that does not have an h value of 0, and that changes your x values. All right, so let's plug stuff in. Do you see parentheses anywhere? No. I'm going to go ahead and put the exponent in parentheses because it's always a good habit. That way your calculator knows for sure what you are considering as an h and what you are considering as a k. So always put your exponent in parentheses. So 2 to the parentheses, -2, close my parentheses because I'm done with my exponent, plus 3. Okay, now I'm going to go back and change that -2 to a -1. Now I'm going to go back and change the -1 to a 0. And then to a 1. Whoop, wrong place. There it is. And then finally change the 1 to a 2, and I get a 7. What do you notice about those numbers? They're all the same values you had in the original one, just adding 3 to it. Do you see that represented in the equation? It's the original 1 plus 3. So let's graph these. -2, 3.25. I'm still just above that asymptote, even though the asymptote's moved. -1, 3.5, 0, 4, 1, 5, and 2, 7. Again, some of you tend to get sloppy with your graphs because maybe you don't like graphing or whatever the reason. But if your graph goes through that asymptote, we're going to have issues. You will be marked wrong for that. Because if your graph goes through that asymptote, you're showing me that you don't understand the nature of the asymptote. That it is a wall, just like I had Taylor showing earlier, that you cannot go through. Okay? All right. Excuse me. What's my domain? All real numbers. What's my range? Y is greater than 3, because my k value is 3 this time. Okay? So? Yes? No? Okay. I'm going to jump to the back side. I was going to do this one, but I'm actually going to jump to decay to do this one. So, let's find the decay one that has an h value to deal with. It's in the exact same spot right here. The only difference between this equation and the one on the growth side is the fact that on the growth side we had 2, and now we have 1/2. Everything else about the equation is exactly the same. Everything else about the process of solving it and graphing it is the same. So, what would you say A is? A would be out in front. There's nothing out in front, therefore it is 1. What would you say B is? 1/2. What is H? Now remember, your parentheses are in your exponent, so what does that mean about H? We always have and we always will change the sign of H. What would you say my K value is? 0. Same thing as the other side. H determines where my XY chart starts. K determines what? Asymptote. So if K equals 0, then my asymptote is at 0. And what's the equation of my asymptote? Y equals 0. So far, so good? All right, so I have -3. Let's see, I'm going to do -4 and -5 and -2 and -1. Now, do you see that there's parentheses already in the problem around the 1/2? So I'm going to keep those parentheses as I type stuff in, but I also have to add the parentheses around the exponent. So 1/2, and you can use your fraction button if you want to. Doesn't really matter here. To the x plus 3. I'm going to start off with -5 plus 3. And I get 4. Interesting, I get a nice number at first. On the other side, I got all the decimals first. All right, now I'm going to go back and change the -5 to a -4. And I get 2. Now I'm going to change the -4 to a -3. And to a -2. There's my decimal. Any guesses on what the next one's going to be? 0.25. Interesting. Same numbers we got on the other side, just in a backwards order. All right, so let's graph these. -5, 4, -4, 2, -3, 1, -2.5, and -1.25. How is this graph different than the one on the other side? It's reflected how? It's kind of reflected horizontally a little bit. The main thing about decay is as you go from left to right, what do you notice about the graph? It's getting closer to the asymptote. Whereas on the other side, it was getting further away from the asymptote. Okay? All right, last problem. Actually, before I get to the last problem, let's talk domain and range. What's my domain here?
All real numbers.
All real numbers. And my range?
Y is greater than 0.
Y is greater than 0. So is there really any difference between solving or graphing an exponential growth versus a decay? Process is the same. All right, last one I want to do with you has both an H and a K in it. All right? So this is about as hard as it gets. So let's figure out some of these letters. What is the B value? Here's your form. Here's your equation. What's B? 1/2. What is H? -5. Remember, parentheses around your exponents? Don't worry about this centered at part. We'll take care of that. What's A? And K? All right, so what helps me with my XY chart? H. right? H tells me what goes in the middle. So negative 5 goes in the middle. What does K tell me? My what? So my asymptote is at negative 2. Yes? Okay. Let's see. What's the equation of that asymptote? Y equals negative 2. And let's go ahead and fill in some values around. I have negative 6 and negative 7 one way, negative 4 and negative 3 the other way. Okay? All right. So there's some parentheses in this equation. I'm going to need to make sure that I put these in there. So 6 parentheses 1/2. Again, you could use your fraction button if you want to. To the parentheses, what's my first x value? Negative 7 plus 5, close parentheses because you're done with that exponent, minus 2. And I get 22. Now I'm going to go change that negative 7 to a negative 6, and I get 10. Change it to a negative 5, and I get 4. Change it to a negative 4, and I get 1, and change it to a negative 3, and I get negative 0.5. So, negative 722 is off my graph, isn't it?
Yeah.
That would be a point somewhere way up here, yeah? Negative 610, I think I can fit on my graph. Negative 5, 4. Negative 4, 1. And negative 3, negative 0.5 is below my x-axis. So I don't know a ton about this side of the graph, but I do know it's not going to cross that asymptote. So let's talk about this domain and range. What's my domain? All real numbers. What's my range? Y is greater than negative 2. And when she asks about the transformation, let's talk about that for a minute. A is 6. What does that mean? I have a what? Vertical stretch of 6. I have exponential decay because of what my B value is. My H value is negative 5. What does that mean? I have a shift how? 5 to the left. And my K value is negative 2, which means I have a shift how? Down 2. Do you know what the parent function of this graph is? Close. Y equals 1/2 to the x would be the parent function there. Okay? That's not as important as you being able to come up with this stuff down here and being able to do your graph. Okay? Questions? All right. Happy studying.